All right, welcome everyone. So we're going to start off today with looking at a set of premises and trying to figure out how to get to a specific conclusion. So in this situation here, we have our four premises. Our goal is to get to P. Now, again, I suggest that you do this on your own first before you check over the material, before you watch the video and check over a solution. There are multiple ways of doing this here, so your solution may not necessarily match the solution that I'm going to give you right now, but I'll try to go through the two major solutions here. So the first thing that is a good idea to do is to look at what statements go together. It seems like these two statements definitely go together. We have R implies T and R. So it seems like we can put these two things together here, right? Because we know that we have a conditional and we have the hypothesis of the conditional met. So it would seem that from here we get T, and this is true by our law of detachment. Right? So we have a law of detachment here allows us to get T. Now, with that, we can continue with this here and continue using Q implies not T here. And as a result, we can do the same thing. Note that we have a conditional and we have the opposite of the conclusion, so the opposite of the hypothesis is true. And therefore we have not Q. This is our law of modus tollens. Okay? So also note that we have that here. And of course, now we can go back to the beginning here. We see that we have P or Q. We also have not Q here. So again, it's a disjunction. We have the opposite of what's going on. This is our law of disjunctive inference here. And as a result, out should pop P here, which is what we wanted. So you can see we were able to put everything together in a nice little flow like this here. We were able to assemble all of our information, marshal it in the right positions, and we ended up with a statement here at the end. Now, this is one way you could do this here. There are also other things that you might have noted. Some of you may have noted that we have two conditionals that we can try to put together, especially since they have a T. They both have T, even though one is sort of in the wrong position. So one of the things we could do, for instance, is contrapositive, to contrapositive of any one of them. You use the law of the contrapositive, and that gets us to T implies not Q here. And now we can put these together by chain rule. Our chain rule here allows us to go that way, and we end up with R implies not Q here. And then here we can put these two together, end up with, and now we have our law of detachment here. And we end up with not Q. And then this looks, and it finishes exactly the same way as our previous one did. We have both these here, and we end up with P at the end here by disjunctive inference. And there you go. So again, note that we have two sort of different ways of doing this here, but they all seem to work out pretty well, right? Now, your method may be, again, different than these two, but I get the feeling most of you have this here. Anyway, the reason that I bring this up is because notice how essentially what we're doing is we're creating a flow here. We're showing how these statements flow into one another, and we can use them to draw conclusions based on this here. So no matter what's going on with all this here, the idea is that at the end we are showing that P is true beyond a shadow of a doubt here. There's no sort of halfway in between or any sort of ambiguity here. P must be true based on the what we know about Boolean logic and also the laws that we've established already. So P, we have essentially shown that it must be true. In essence, we have proven it to be true. Now, this is fine and all, but it can be a little messy, especially if your handwriting is not as, your handwriting is messy like mine here. Yours can, your method, this may be a little hard to read. So there are other ways that we can go ahead and look at this here. And one way we can do this is by looking at what is known as a proof here. So essentially what we have here, this is a sort of an outline of a proof. You can think of a proof as a sort of a mathematical essay. So it's a mathematician's equivalent of an essay. And now I know what you're thinking, oh my God, I only got good at math, so I didn't have to write essays. And, I guess you have a point there. But, the nice part about these proofs is that we can, take some aspects of what makes us mathematicians and write these a little bit more efficiently. So as an example, let's have a look at this here. So based on what we saw in the do now here, what we saw in the beginning, this is a sample proof here. And in fact, you'll note this is actually corresponds to the plan that we have here in black here, right? This plan here, it corresponds to this. So you'll note that first off, it's a lot neater. And a couple things to note here, so I want to talk about a couple things about the components here. So, I've left some room down here for you to take notes for this here, so you can go ahead and do so. You'll see that in this situation, we have a couple things here. First things first is the proof itself. This is the proof itself. Note that we have ourselves, we write these out to the left here. All of these here are going to be our premises here. Right? So every single one of these things here is a premise here, whereas P at the bottom here is our conclusion, or our goal here. That's what we want to prove. Okay? Now, in this situation, this is just sort of gives us, these are the facts in the case, so to speak. This is what we start with, and this is the eventual goal. Now, over here on the right-hand side, we see that we have ourselves the actual proof itself. So see, this is known as a two-column proof here because there are two columns, as you can see. One for statements, one for reasons here. So a couple things to note. First off, there are statements and reasons here. Every row, everything is numbered here. So you have row 1 here with these two things and so on and so forth. You'll also know, if you look at the reasons here, if we want to focus on the reasons come in two flavors. They're either given, in which case, it's because they were a premise here. So notice that these are all premises here. So here's a premise here and a premise here and so on and so forth. All these are premises here. Or there are a specific law here, right? There's a law that relates these statements together. So you can notice how in this situation, right? So if we go back to the picture that we had in the beginning, going back here, the first thing we did with the law of detachment on R implies T and R, and that got T at the end. So you'll note that is reflected here as well, right? We use R implies T and TR, and we got T out of it, and that's going to be our thing like this here. The same is going to be true with the rest of this here, right? So you can see, actually, if you compare this to the initial slide here, you'll note that it follows an order here, right? There's a law that relates these statements together. You also note that these are labels here, right? The labels here, 1, 2, 3, 4, 5, 6. This tells you here, and I think it's pretty clear to see what's going on here. These are the steps used for each law here. So most of these steps will require two numbers here, because most of the laws that we've looked at will require two components in order to do anything with them. There are certain laws like De Morgan's law and contrapositive that will only require one, in which case you only need one label, but that's okay. So notice how here we were able to take everything that we did over here in our initial position here, our initial thing here, we were able to take that and compress and condense it into a rather nice looking table here. Okay, so we can see that this is our table. It looks pretty good. So when we're writing our first proof here, right, now let's go ahead and actually write this one out. And we're actually going to spend some time writing a couple of these proofs out here so we can see what's going on. Okay. So when you're writing a proof here, right, so let's consider a very simple proof, something like this here. Right, so you'll note that there are several steps that we're going to follow here. So in this case, if apples are red, bananas are vegetables. If apples are not red and candy is delicious, bananas are vegetables. And we're going to prove the candy is delicious. Pretty good way to start things off. So note that in this situation, the first thing to note is that this is all in words here. So just like we've been doing previously, it's a good idea to convert everything to symbols. So our first step here, what we're going to do is we're going to convert all the statements into symbols. Now, there may be certain situations where they're already in symbols, in which case you can skip step 1, but we can do that here. So let's see, we have apples. So let's see, if apples are red, I'll say that's A. Then bananas are vegetables, that's going to be B. So here's A, here's B. Apples are not red, that implies a not A here. Then candy is delicious, I'll call it C. Bananas are not vegetables, so that is not B here. And as a result, our goal is to prove C. We want to prove that candy is delicious here. Okay? Now, some of you may already be able to see how to do this here, but some of you may not, and that's perfectly okay. I made this analogy here, how this is similar to that of writing an essay. Now, of course, when you write an essay, it's very unlikely, unless you're very experienced or you really know what you're doing, it's very unlikely that if you are writing an essay, you just jump right in and write it, right? You want to actually set it up first. So they often tell you it's a good idea to create an outline. So we're going to do the same thing here. We're going to construct an outline. And that outline is very similar to the plan that we did before. So what we're going to do, our second step here is going to be we're going to construct a plan for the proof. Okay? So this plan is basically, you think about this as just us writing it all out, and then we can convert it into the table. So there are several ways you can work on this here, and of course you can just look at this here. I'm going to do this as simple as I can. I notice the A implies not B and not B here. Sorry, A implies B and not B here. I'm going to use these two and use modus tollens here. And that will yield us a negation of A. And you can see that with the C here, with the other conditional here, we can use detachment. And we end up with C here at the end. So, you know, we have a relatively simple proof, so it actually works out pretty well. More complex proofs will require slightly more complex plans, but there's no big deal behind that. And then finally, what we're going to do is we're going to write the table. And the nice part about constructing a plan for the proof is that if you constructed a plan for the proof, the table, I mean, you're basically done with the proof. It's just a matter of organizing everything. So now, let's write this out. Statements and reasons here. So I can already hear some of you asking, do we have to do step 2? For the time being, I suggest that you do step 2, but as you get better at writing, as you get better at these Boolean logic proofs here, it's not necessary anymore. If you feel like you can just jump in and do what you can, then by all means go ahead and do so. But for now, I think it's a good idea for you to write things out first before you get going. So we know that in this situation, the first thing we did was modus tollens. So I'm going to introduce the two givens. So you have A implies B, that's a given here. Step 2 is not B, and that's a given here as well. Now step 3 here, right, we can put these together. Now we saw that we used the law of modus tollens and we got not A. So this is our law of modus tollens on steps 1 and 2 here. Okay. And then now we saw next that we introduced the next given, not A implies C. That's a given here. And then finally, we can use C, we can get C at the end by law of detachment on steps 3 and 4 here. So we see that in this situation, we were able to convert something like this into something like this, and it worked out very nicely. We see our proof is written very nicely, and we're going to be in good shape.